Hello, so problem number one of my code asked me to just pick a dependent variable. In this case, I chose the bank balance to be my dependent variable because I expect things like job, age, marital status, and things like house loans to affect how much money a person will have in their bank account, and also because it was a numerical value already. Some predictions that I have is that middle-aged people are going to have the most amount of money because they're not saving up for retirement, but they're also old enough where they have some money to save, while people who have good jobs. Obviously, various jobs going to affect how much people make and therefore how much they have in their bank, how much their bank balance is, and then things like whether they have a loan or not. I expect people who have loans to have less money, therefore a lower balance, because that's money that's going to that loan every single month, paying off that loan. Then this is just a quick correlation table of balance and balance against everything, so our dependent variable being balanced and it um we want to see how those correlates amongst everything else. And we see here that between all of these variables, none of them are too strong, but age is the strongest one. So I chose age to run my simple regression. So as we see over here, although the p-value is at 0, the r-squared is only at 0.007, so that's not very good. So because of that, I said that this model is probably not very acceptable to predict future bank balances, just because even though the p-value was very small, the r-squared was also very small, and that's not great. And then in order to do my multiple regression, I wanted to include all of these variables, and as you could see, the bank data set doesn't have very many numerical variables, and we need that in order to do the multiple regression. So I just turned every single one of these values into some numeric form. So we see that I did that for housing. So guess if they had a housing loan, no, if they zero if they didn't, and that would be 0, no, 1, yes. Same thing for the loans. And then marital status, job, default. Like I said, I did every single one of the variables that was numeric. And for here, you obviously see that I set the date of the month to be just their numeric values, and then turn that into integer. And then we see here we have all these integers at the bottom, the ones that we just made, so the integer values, but we still have some objects here at the top. So, and then I also went ahead and I did set my bank balance to be the last column, just because it made things easier when we called it to set it as our Y. You see, we get this huge table. It has 25 rows in it, and then I just deleted the categorical values, so those variables that had the object as their data type, and I just went ahead and deleted them. So now if we check our new bank 2 table, we see that it is simply all numeric values and we don't have any object values or any categorical ones. Go ahead and check that. See, no object data types. And then for our X and our Y, this is why I wanted to set the bank balance to be the last column, just because it made it easier in doing all this. And then in this is when I ran it with all 15 variables, and you see that our r-squared really didn't improve all that much. It's still just a 0.028, big improvement, I guess, from 0.007, but still. So then I went ahead and deleted a lot of these. I believe it was like 10 different variables here because they all had a p-value greater than 0.05. And then you could see we're setting the x in here to be all of the variables, and we're doing that because each one of the variables has a column number set to it, so we're selecting every single one of those columns. And this is calling setting those as well. So we're doing 15, which means that the bank balance is in the 15th column, and that is why. And then for X, we're doing all of them minus the last one, so minus the bank balance. So after taking out age, month, campaign, P days, a previous housing, and that's supposed to be num, low num, marital num, P outcome, and balance. because like I said, those were the ones that had the p-value larger. We see that our p-value goes up about 10 times, so now it's 0.203, so that's a lot better. And now you see over here that all the p-values are basically 0. Then I went ahead and played with it a little more, and I realized that even after, when we took out the job num, default num, and ynum, which did have a p-value of 0, it only affected our p-value by 0.003, and that's really close to nothing, especially when you're considering how you're taking out 3 whole variables. So I thought taking out those 3 variables seemed worth it, because in the long run it was going to save us storage and runtime, and basically still give us the same r squared value. And then over here, this is when I started, I wanted to test the quality of my multiple regression. So I want to see how what the predicted values from this formula would give us if we were to compare those to the actual values. So right here, we're just doing our train set. So we're training our equation with this, and we're testing it. And same thing for testing the y. And then this is just making sure we label them and seeing the size of those. Over here, we're going to see how accurate our model is, and it only has a 2.9 accuracy, which isn't the best, but we're going to go ahead and move forward with it because this is the data set that we got to work with. Then just printing it out, making sure what the y predicted r is, excuse me. And then we can go ahead and print out the predicted that we have, and that our equation that we created had compared to the actual. And as you can see, doesn't really line up. I mean, here we have the actual was 0, but we predicted to have over $1,500, and you can see how off that is. And I mean, I guess same thing for this person who had $7,000, and we predicted them to have only a little bit more than someone who had 0. So not a great prediction. And here, I'm just making the last column for the logistic regression model, I'm choosing lone num, so that just basically means whether a person has 0 is they don't have a loan, 1 is they do have a loan, so yes to the loan. And I chose this variable in order to meet the first assumption of a logistic regression, which is that the dependent variable is supposed to be binary. And over here, I'm just inserting it back into the last row since I deleted it over here in the first one, basically. Then we see in this correlation chart, there's a lot going on and it's kind of hard to read, so I went ahead and used that Seaborn to make it a little bit easier. We see that the lone num and the the house num have a 1-to-1 ratio, so we're just gonna go ahead and delete those. And so yeah, we're gonna go ahead and delete that one. I mean, same thing for the job num. I'm now realizing that forgot to delete that one as well. And that's simply because they have a 101 correlation, so we don't want them to be playing with our logistic regression. So you see right here, we have the 1 correlation to housing, and it's also a pretty strong, housing has a 1 correlation to. So yeah, we would delete those. Actually, it does not need to be deleted, but I can't run that again, so it's fine. And then we're going to set our training set to be very large, so it's going to have all the values from 0 to 3,000, because we have a 4,250 rows in this data set, so it's a very large data set, and so the training is going to have 3,000, while the test is only going to have about 1,200, and then it's only going to check these last few 50 values, just because more than that wouldn't really be necessary. We're just going ahead and writing all of that so it knows what to look at. And this is just comparing it like obviously, when you want to see the difference, we want to do the predicted mean, the actual mean divided by the standard deviation. We see that all of that is working out great, and then we see that our accuracy is actually pretty great here. It's 66.92. It's a lot better than we would have saw for our previous regression models. And then over here, if we do the full comparison, we see that for the most part it is right. I mean, right here is an error, but it does seem to be pretty accurate. You see ones and zeros in the same rows for the most part. And then I did consider this an improvement, the logistic regression to be an improvement to both of the other two regressions, because in the simple regression, we were only comparing age to balance. We only got an R-squared of 0.007, so that was not great at all. And then even when we did the multiple regression, we still only got an R-squared of 0.203, which isn't awful, but also not that great. But when you compare this to the fact that our logistic regression has 66.92, we see that that is a much better predictor and a much better model all around. And yeah.